So in this video I would like to look at some examples of integration by parts. Integration by parts is one of the most important integration tools you can learn, and when you master it, it's going to make your life so much easier. So how do we do it? Well, the formula for integration by parts says that the integral of u dv equals uv minus the integral of v du. So what does all this mean? Well, this means that you call one part of your integral u and one part of it dv, and using this integration by parts process, you can change your integral into something that's much more easier to deal with. And the basic idea is that you're going to pick u to be the thing you're differentiating and dv to pick the thing you want to integrate. So this might look a little bit confusing, so let's look at some examples. So our first example is I've got to integrate x sine x. Now, as a general rule, I'm going to try to pick u as the part of the integrand that was going to make my life much easier when I differentiate it. So I could choose u to be x, or I could choose u to be sine x. But remember that if I choose to differentiate x, then that means that I've got to integrate sine x, and likewise if I choose u to be sine x, that means I've got to differentiate x. So which of these options is easiest to me? Which of these is going to make my life easiest? Well, in this case, if I differentiate x, I know that's just going to give me 1. So that's something that's probably going to make my life easier. So let's do that. Let's choose u to be x and see what happens. Let's choose u to be x. And remember, if I pick u to be x, that means I've got to pick dv to be the other thing. That's sine x dx. Whatever's left over, basically. So that's sine x dx. So u is the thing that I differentiate. What happens when I differentiate u equals x with respect to x? Well, this is just going to give me du equals 1 dx, which is very useful. And what about this? Well, I've got dv equals sine x dx. Well, if I integrate both sides of this, this is just going to give me v equals, well, what's the integral of sine? The integral of sine is minus cosine dx. So now all I have to do is use my formula. My formula for integration by parts, so that I take uv and I subtract the integral of v du. So first of all, what is uv? Well, uv is just x times minus cosine of x. So my integral is going to become this. It's going to be uv, which is x times the cosine of x, minus the integral of v du. Well, v is minus cosine of x, so that's minus cosine of x. And I've got to multiply that by du. In this case, du is just 1 dx, so that's just dx. I don't have to write them 1, because multiplying by 1 is just nothing really. So what is this? Well, I've got a minus sign here and a minus sign here. A minus and a minus make a plus, so this is the same as x times the cosine of x plus the integral of cosine of x. And notice that this has made my life a lot easier now, because I've taken something that I couldn't integrate, I couldn't immediately see what the integral of x sine x was, and now I've changed that into x cosine of x plus the integral of something that I know how to integrate, and I hope you know how to integrate the cosine of x. So what's the integral of the cosine of x? Well, that's just sine x. So this whole thing becomes x cos x plus sine x. And because this is an indefinite integral, I've got to tack on a plus c. So there's my answer. X times the cosine of x plus sine x plus c. And that's all there is to it. So let's look at a different example. So in this case, we've got the integral of x times e to the 2x. So which of these is easiest to differentiate? Well, again, the easiest to differentiate here is x. So I'm going to choose u to be x. And just as before, dv is going to be whatever I have left over, which is in this case e to the 2x times dx. So that's e to the 2x dx. Well, if I differentiate u, I'm going to get du equals dx. And if I integrate dv, well, what's the integral of e to the 2x? Well, that's just going to be a half e to the 2x. So that's a half e to the 2x. So my integration by parts formula says that I've got to multiply u and v. So what is that? Well, u times v is just x times a half e to the 2x, which is the same as x over 2 e to the 2x. I've now got to subtract v du. So I've got to subtract the integral of v times du. Well, v times du is just half e to the 2x dx. So that's a half e to the 2x dx. Well, again, I've now got something that I know how to integrate. I've got the integral of half e to the 2x. And I know how to integrate e to the 2x. So this is the same thing as x e to the 2x over 2 minus a half times the integral of e to the 2x dx. And what is this? Well, we've already done it. We know that the integral of e to the 2x is a half e to the 2x. So this thing just becomes x e to the 2x over 2 minus a half times a half e to the 2x plus some constant c because it's an indefinite integral. And simplifying this is just x e to the 2x over 2 minus e to the 2x over 4 plus c. And that's my answer. So those are some examples of applying integration by parts to solve some integrals, and that's really all there is to it. So if you'd like to see more of this, let me know in the comments below, and don't forget to subscribe if you liked what you saw. Thanks.